Hi, so in this video I'm going to talk about one of my favorite searching techniques, and the name is linear search. Well, linear search can be optimally applied on an array, or you might consider it as a container, right? Container of a string or numbers, right? So it can be applied on a container or an array or a list, whatever you may call it, which is not sorted, right? So, but if it's sorted, right, then ideally we can use binary search or ternary search, but that's the other case. Now consider an array, right? I'm just going to write an array here, and just for the example purpose, I'm going to take a very small input here, right? So it's better to learn any technique just by dry running a small code or small piece of test case. Now consider my array has elements like 10, 9, 11, then 3, 2, and then for example 100. Now notice one thing, that my array is not sorted. So when the array is not sorted and I have to search anything, then definitely you can use any built-in function, but for the sake of interview purpose or maybe for the sake of knowledge, you have to know about the linear search technique, which can be applied optimally on an array or a container which is not sorted. So how do we do that, right? So we make use of one pointer. So let's just call that pointer as first pointer, right? Because we only have to make use of one pointer, right? First pointer, and there will be no other pointers. So for example, second, third pointer, there will be nothing as such, right? So where is the first pointer going to point at? Is it going to point at the middle of the array, or the end of the array, or the beginning of the array, right? Now, since I mentioned that this is a searching technique, so let's just consider a number which we are searching, and let the number be 3, right? Let the number be 3. So how do we go about proceeding and searching the element, or maybe the index, right? So definitely by common sense you can kind of figure out, or you might have figured it out, that the first pointer is going to point at the 0th index. Well, I'm going to write the indexes on the top. That's 0, 1, 2, 3, 4, and 5. That makes sense. And the first pointer is going to point to the first index. And how do we get the element? We can kind of get it like this. So array of first pointer. So this is how we are going to access the elements, right? And where is the first pointer currently pointing to? First pointer is currently pointing to the index 0, if that makes sense. Now we are going to make use of the simple concept of for loop, or you can even use the while loop. So this is going to write a small pseudocode, right? So the pseudocode would look like this. So my first pointer, right? My first pointer will be at 0 initially. So let's just use for or while loop. So I'll just go randomly. I'll just use while loop. In fact, for loop is quite faster than while loop. You might prefer for loop, but just for the randomness, I'm just choosing while loop. So I'll have to write while first pointer is less than n. Now you might be wondering what n is. So n is basically the length of the array, right? So n is the length of the array. In this case, the length is basically 6. So this is going to go till 5, because we all know that the indices start from 0, so it will be 1 less than n. So you can even write this as first pointer while first pointer is less than equal to n minus 1, and that will also kind of make sense, right? Now what do I need to do? So when I'm at first pointer, I need to check what is my current element. So I can kind of write that my current element, right? Current element, or the element at the current index, right? You can kind of figure it out. So current element is basically array first pointer. So it means that the element in the array at the first pointer position, right? I think I messed up with the pointer thing, so that makes sense. So first pointer. Now what do I need to do? I have to just make use of a simple comparison operator, right? So this is one of those arithmetic operators where you compare two things, right? Not necessarily two numbers, but you can compare two strings and so on. The thing goes on, right? The list goes on. So you have to just write here that if my current element, right, if my current element, the element I am at, is actually equal to the number I am searching for, right? So this is number here, right? If that is the case, then I'm going to set a variable like found is equal to 1, and then I'm going to break here, right? And where do I get the variable? Well, I missed in the declaration part. So found can be written as 0, or you can even go for 0 or false, and in this case over here you can write 1 or true, right? It never matters, like you are checking for a true condition, right? So found will be true, and then I'll break. Else what I'm going to do is this part. So else I'm going to increment my first pointer by 1. So first pointer will be equal to first pointer, whatever the value was, plus 1, right? So this is just for your understanding purpose, but if you're quite aware of some faster operations, then you can even write this whole thing as, for example, first pointer, right? So this is first pointer, I'm writing it in short, plus is equal to 1, right? So this is kind of faster than this method, right? Now this is where an interesting part comes in. So at the end of the day, you have to check that if found, right? So if found. So if you find the element, right? If you find the element, then this will be 1 and this will be true, right? Or it might be 1 or it might be 2. So this is going to execute, right? Once this executes, you can just simply print that element is found. Else, in which case you are not going to print. So for example, I never encountered this condition. So for example, the number is not even in the array. So I never encountered this condition, which means that my found is 0 or false, right? So this means that it's not going to be true. So I'm just going to print element not found. And that's the whole entire pseudocode, right? The entire working of linear search. So let's just dry run this, right? So my first pointer will be at here, right? So my first pointer is here. So I'm going to write it in short, FP. Notice what I'm saying. So FP is at 10. So is 10 is equal to 3? No. So I increment FP. Now FP is pointing here. Is 9 equal to 3? No. So it's at 11. 11 is again not equal to 3. And once I encounter 3, 3 is equal to 3, then my condition, which condition? This condition is going to match, and I'll just break with found value updated to 1 or true, whatever the case may be. And that's how the linear search algorithm will work. Well, you might have figured out the time complexity or the space complexity. Well, what is space complexity? So space complexity is the additional memory or the auxiliary memory you use to write your piece of code. Well, over here, you can kind of count the variable as an additional memory, but that not really plays a strong part in the long term, right? So we kind of ignore the memory occupied by the variable. So we kind of count the memory occupied by an additional space like an array or a container or a memo, like unordered maps in C++ or hash maps in Java, and so on. You can kind of make sense, right? So the auxiliary space over here is nothing. So I can kind of say that the space complexity, which I'm denoting by SC, is big O of 1, right? Now, what will be the time complexity? Let's just figure it out. So I'm going to write two cases here, right? I'm going to write two cases. So this is my array, right? This is my array, and some numbers are there, right? Some numbers are there. What if I'm searching for, so for example, the first number is 1 and the last number is 10, right? So for example, first number is 11 and last number is 10. Now, what if the number I'm searching for is 11? Then what is the time taken to find 11? Well, when my first pointer is at the beginning, which is at 0, 1, 2, 3, 4, 5, 6, when the first pointer is at 0, I kind of find 11 there itself. So the time taken is kind of negligible, right? So I can kind of say that as big O of 1. But what if my number is 10? Then in that case, first pointer will kind of increment to 1 2, 3, 4, 5, 6. And when it comes to 6, it kind of sees that 10 is equal to 10. And that's where we find the element. So what is the time taken? Or what is the time complexity in other terms? Well, the time taken here will be nothing but the length of the array itself. Length of the array. I'm just going to write it in short. So what was the length of the array, right? How is the length of the array denoted here? So you can see I've written here in clear terms that the length of the array is n, right? So you can kind of figure it out that in the worst case scenario, that's worst case. So in the worst case scenario, the time taken will be big O of n. So that's how the linear search algorithm works.